Hello everyone, myself Majal. I'm a Masters in Physics candidate at Christ University, Bangalore, India. I'm really glad to be a part of this Commons in Space virtual conference. I'm here to give a talk on space debris removal methods a review. Today, satellite applications are inevitable in every field of study. With the impending increase in space debris in their orbit, satellites are subjected to an increased amount of debris impact risk, and it is essential to remove at least 5 to 10 large debris from LEO every year to use it in the future. In this talk, I'll give a summary of the most common space debris removal methods proposed by various space agencies across the globe. We classify the current space debris removal methods into the following four types: capture methods, contactless methods, drag augmentation methods, and modified launch vehicles. A net ejector mechanism ejects a net from a canister. In each corner of the net would be a mass. The purpose of these masses is to pull the net open during deployment. The net would reach its full size just before impacting the target debris and would wrap around it passively, the motion driven by the inertia of the corner masses. Once the target debris is fully wrapped up in the net, the tether would be tensioned by the chaser and the deorbitation burn would commence. A harpoon mechanism with barbs on its tips can be shot from chaser satellite and penetrate itself into a large space debris object. Chaser satellite will pull the debris to re-enter or to a graveyard orbit afterwards. One of the primary advantages of this method is that it is compatible with differently shaped targets, but its primary disadvantage is that there is a great risk of generating new space debris during penetration. In laser method, pulsed laser beam shoots into space debris to decrease its velocity and start deorbitation by lowering its altitude. Ion beam shepherd is a concept of ejecting a highly collimated neutralized plasma beam onto a debris object and lowering its altitude. An artistic impression of the same is given here. During a typical mission profile, the IBS would rendezvous with the target debris, and while co-orbiting at a constant distance, it has one of its beams constantly pointed at its surface to produce a small continuous drag force, while the other ion beam would point at the opposite direction to keep the relative distance constant. This way, the IBS can be used to remotely maneuver space debris without physical contact like docking and can be repeated for multiple targets. The force transmitted comes from the variation of momentum of the plasma ions impacting against the surface of the object and penetrating its outermost layers before being stopped. The Cobra concept is very similar to the IBS method, except that it uses chemical propulsion rather than electrical propulsion. Propelling atmospheric particles like gaseous plume or a vortex orthogonally to the path of the debris to decelerate the debris velocity and start deorbitation is called artificial atmospheric influence. If the satellite can capture space debris and eject it towards the Earth and then slide to another space debris by applying the momentum generated from the ejection of the initial space debris, then the method is called as slingshot method. Adhesive method was proposed by Astroscale Singapore, in which a deorbiting kit called buoy, equipped with a propulsion system, can be released from a carrier called mothership. The buoy adheres to a tumbling space debris, then removes it from its original orbit and causes deorbitation. Expanding foams method. The foam carrying spacecraft sprays the foam from a distance to the debris onto which it is assumed to stick while expanding. The underlying principle of the method is to increase the area to mass ratio of debris in sufficiently low Earth orbiting debris in order to increase their natural atmospheric drag and thus substantially decrease their natural orbital lifetime, leading to their natural re-entry. If we use inflated balls instead of foam, it is called inflated method, and if we use fiber instead of foam, it is called fiber-based method. UWDES stands for Ultra Thin Wire Drag Enhancement System. Due to their tensile strength limitation, these thin wires are cut into numerous strands of short length and bundled together into a tuft. The ends of all the strands are clamped together at each end of the tuft. It is deployed by a simple lid release mechanism which is followed by electrostatic charging, which leads to the formation of a three-dimensional structure by mutual repulsion. The tuft of ultra-thin wires and the interior of the container in which they are stored are polarized with like charges so that the wires repel with the container and the central barrel of the spool unwind and move out of it gently. Once out, the wire strands move away from each other due to mutual repulsion. Here, as all the individual wire strands are clamped together at both ends of the tuft, they arrange themselves into various shapes or configurations based on the strength of mutual repulsion between them, the drag force acting upon them, several wire strands present, and the effect of gravity gradient stabilization. Also, one end of the wire is anchored to the container to prevent the elimination of direct contact of the wire with the container and the nearby component or structure of the spacecraft. One of the merits of this method is that it results in greater aero drag effect in comparison to drag sails or gossamers of the same dimension. Considering only the aerodynamic effect, it can be used in lower Earth orbit with nominal performances, but with the inclusion of its Coulomb drag, it can be utilized till 6,000 kilometers, which is the outer limit of the Van Allen radiation belt. It is also proposed to modify launch vehicles to remove space debris once their primary payload injection is completed. Modifying a launch vehicle's upper stage by the addition of EDT or electrodynamic tether and a grabbing mechanism can be used to remove space debris. In addition to the grabbing mechanism and EDT, the system also requires deorbiting subsystems for propulsion and attitude control. Once the primary payload is injected into an orbit, the upper stage proceeds to debris removal by using the grabbing mechanism. The grabbing mechanism proposed is Kevlar 49 braid, and the parameters are given here. And the EDT system is also used as a propulsion system. And an picture describing the principle of EDT is given here. The JAXA Institute of Aerospace Technology is studying an active space debris removal system consisting of a microsatellite that utilizes electrodynamic tether or EDT technology to transfer large debris object to a graveyard orbit. In LEO, the influence of the Earth's electromagnetic field is strong, so the use of an EDT is practical. LEO also has the greatest risk considering its debris collision probability. The LEO debris removal system is named as Space Debris Micro Remover or SDMR. And these are some of the papers which I have referred. Once again, thank you so much for the opportunity. If you guys have any questions, feel free to email